Okay, for this video, we're going to look at the limit as x approaches 0 from above of x to the x. The key idea behind this problem is that we will use the idea that b to the a is equal to e to the a times the natural log of b. And therefore, the limit as x approaches 0 from above of x to the x equals, okay, in this case, they're both the same, but the a is x, the b is also x, and so this becomes the limit as x approaches 0 from above of e to the x times the natural log of x. Okay, so the idea is that we will examine the limit. So I'm going to switch colors, and I'll come back to this original limit up here in the first place. So we examine the limit, the exponent, the limit of the exponent. This is the limit as x approaches 0 from above of x times natural log of x. Now, the form of this is going to be 0 times infinity. Because if obviously the x goes to 0, this part goes to 0, and the natural log of x as x goes from 0 from above goes to negative infinity. So this has the form 0 times infinity, just like the form of up here was 0 to the 0. If I plugged in 0, I'd get 0 to the 0. So these are in indeterminate forms. Now, the technique when I have a indeterminate form that's a product is to force it to look like a quotient. And what I will do to make that happen is the limit as x goes to 0 from above of natural log of x divided by 1 over x. Now, that looks like a kind of an unusual step. Ordinarily, you would take something that like this that's more complicated and then multiply by the reciprocal to get the x here on top. So that's a very unusual simplification step, but it does prove to be helpful because now this is now in the form of infinity over infinity. And so L'Hopital's rule applies. So the new form of this is infinity over infinity. And so L'Hopital rule applies. And so I get the limit as x approaches 0 from above, the derivative of the top, which is 1 over x, over the derivative of the bottom, which is negative 1 over x squared. And so this is the limit as x approaches 0 from above of 1 over x times negative x squared over 1. And so that simplifies to be just simply x by itself, or actually negative x by itself. And clearly, as x goes to 0, that goes to 0. Okay, so the exponent here goes to 0, and therefore I can now plug into the original equation. So therefore, the limit as x approaches 0 from above of e to the x natural log x is equal to e to the 0. And then anything to the 0 is equal to 1. And so that is my answer. The limit as x approaches 0 from above of x to the x is equal to 1. And so that's the answer. Now, we can confirm this calculation by looking at a graph. Now, again, I should emphasize the graph does not prove that this works. You should not look at the graph to simply say, oh, there's the answer. But the graph can be used to double check your work to make sure that you didn't make a silly mistake, computationally. So here's the graph of y equals x to the x. So this is the graph of y equals x to the x. And we see as x approaches 0 from above, the y coordinate gets closer and closer to 1. And so that is a visual confirmation of the calculation that we did here. The limit as x goes to 0 from above of x to the x is equal to 1.